Hello guys, welcome to .NET Tweaks Introduction to React. Myself Bhavna Gunwani and I am software developer as well as corporate trainer in .NET technologies and UI technologies. In this session we will be talking about Introduction to React, React history, advantages of React, who uses React in real approach, React ecosystem, and the comparison of React with other client-side JS frameworks. React is a JS library developed at Facebook for creating the user interfaces. Basically, it is designed to build some interactive and stateful reusable UI components that changes the data over a period of span time. It is used to develop view layer of an application from MVC approach, which is model, view and controller. React splits the entire application into various smaller components, and those components combines to make a single page effective application. This makes the component isolated and reusable piece, which can make our application more robust. As when this program is designed, the latest version of React is 16.6.3. Basically, React was developed by Jordan Walk, a software engineer, worked as Facebook. First developed on Facebook's Newfield in 2011. Then later on Instagram.com in 2012 was developed. It became an open source framework in May 2013. Afterwards, a React native was announced at Facebook in March 2015. React Fiber was introduced in April 2017 by Facebook to become the foundation of React framework. The initial releases of React was based on minor versions starting from 0.1.0 to 0.1.4.x. In April 2016, React 15 was announced and switched to the major version of release, as the latest version of React is 16.4. There are few great advantages of using React. It is easy to learn and easy to use as compared to other client-side JS frameworks and latest in trend. It implements the JSX syntax, which is a combination of JavaScript and XML to implement the programming concepts. It also uses a concept called virtual DOM that basically selective the rendered subtree of the nodes based upon the state changes in HTML DOM. It implements the client-side and server-side rendering in the real-time approach or application. As discussed, React has reusable context of components which make our application more robust, reusable and interactive. React follows the one-way binding from parent component to child component respectively. We can also test and unit test the React components after the creation that will be discussed into the unit testing concepts of React. There are few companies who are using React because React is declarative style of programming which allows us to focus how your application should look instead of being concerned about the implementation details like DOM updates, control flow and so on. So with this imperative style of programming, Facebook, WhatsApp, Walmart, Netflix, PayPal, Yahoo and so other companies are also using React nowadays. React has its own ecosystem for open source projects that fundamentally change the way of building the React application. The most popular open source projects of React ecosystem includes NPM, Node, Babel, React Router for SPA, as well as Webpack and ECMS 6 as well. In the next session, we will be discussing about getting started with React and React CLI to develop the React application as well. Thank you so much, guys. Hello guys, welcome back. In this session we will be getting started with React application. We'll be talking about React command line interface to create the React application, React initialization process and the folder structure, how virtual DOM works in React. To get started with React, we need to install the React CLI tool, which is known as CRA, Create React App. For that, we need to check whether Node.js and npm is installed in our machine or not. Let's switch to command line interface. To check the version of Node installed in my machine, there is a command node --version. The latest version of Node.js installed is 10.13.0. To check the latest version of npm, we have a command npm --version, and the latest version of npm installed in my machine is 6.4.1. Afterwards, we need to create the application with Create React App, which is a global package installed in the machine. We can also check whether Create React App is installed in my machine or not. For that, we can simply write down create -react -app -version. If React component is already installed in my machine, it will display you that it is 1.5.2. Otherwise, we can run the following command npm install create react app global to install the CLI tool in our machine. Let's execute this command. Create react app -g, or you can write down --global. This will install this CLI tool globally in my machine to create my further React applications. Once this Create React App CLI tool is installed, I can rerun my Create React App version, and it is being modified with the latest version as well. Afterwards, to create a new React project using this CLI tool, we simply need to run the command Create React App space the name of the React project. For that purpose, you need to navigate to the specific folder directory. Let's go to F drive. I'm creating a empty directory for React projects. This project directory is already existing in my F drive. Let me rename this to project repositories, reps. Let's dig inside this create React project reps. Now you need to create a new React app using the CLI tool. For that, we just need to write down create React app space name of your first React project. I'm just naming this as React Fundamental. This entire process of creating a new React app may take time, because during the creation of the folder structure with this command, it also installs the relative packages that require, that is React, React DOM and React scripts. Once this application is successfully created with the fundamental packages as I discussed, React, React DOM and React scripts, we need to go inside the project, which is cd project name React fundamentals, and then we need to run our application using npm start. This will execute the React Bootstrap component, which is by default available in the React application in this folder structure. Later, we can also modify our application components as per our requirements. So by default, my React application runs with localhost port number 3000. We can also customize these configurations later with the help of some configuration package managers as well. This default React component gets rendered successfully, we need to open this React application in any of the IDE just to modify the component or the application as per our requirement. I just require Visual Studio Code for the further implementation. You can also use Sublime Text, Atom, WebStorm, or any other IDE on which you are comfortable. I'll simply go to F drive, React repository, cd project name, and once I'll write a command code dot, it will open the Visual Studio Code, and over this Visual Studio Code this selective folder will be open, which is React Fundamentals. So I can see that the React Fundamentals folder is successfully open over the Visual Studio Code, in which we have already designed folder structure with this CLI tool, which is Create React tab. Further, we can customize this folder structure as per our requirement. Once I'll see the first folder, which is a node modules, which actually stores all the local packages inside this. Later we have public folder in which index.html is placed, which is the page template for the entire React application. Afterwards, there is a third folder, src. In src, we have index.js, which is the JavaScript React entry point, where the root component is rendered, which is app, coming from app.js from the current folder. And here in app.js, this is the HTML or a JSX syntax which renders to my default npm application, which is the output. There I'm getting logo of React along with the link and the text. As per the further requirements, we also have app.css where some cascading style sheets are placed. We can also customize this cascading style sheet. As we discussed over our implementations, we have testability component implementation in React, where we can implement the unit testing. For that we have app.test.js. Similarly, whichever component you keep adding into your application, you can write the test file for those components separately as required. Afterwards, once I created my application successfully, we have a React initialization structure, where we already discussed about the folder structure of the React application created. As we discussed, in the public folder we have an index.html, which is the page template. In src we have index.js, which is a JavaScript entry point from where my app component gets called up. The third very important implementation is whenever we create subdirectories inside our React application, we should create those subdirectories inside the src folder. Whatever you create inside the src folder, that is implemented for faster rebuilds. Only files which are placed inside the src are processed by the Webpack for the bundling. You also need to put any JS, CSS or any scripting files for the further implementation inside the src along with the test files as well. Otherwise, Webpack wouldn't see them, so your application will not be rebuilt and compiled properly. Afterwards, as we discussed in the introduction section, React has a very intensive virtual DOM to be implemented. Let's say this is my application. As I discussed that the moment we create our application, the by default index.js, which is the main JavaScript entry point for my entire application from where my app component gets called up. This is my root component. If I change anything in this component, let's say by default I'm getting this header along with the logo, text and link. Let me remove this and just write down simply in H2 heading 2 React root component. The moment I'll write this React root component in place of the existing JSX return in this app.js file, I will automatically see the component has re-rendered and the modification has done. So here in virtual DOM, just like a real DOM, in virtual DOM we also have a node tree that lists the elements and their attributes and the content as objects and their properties. In React, for every DOM object there is a virtual DOM exists that has same properties and object as real DOM. Whenever we manipulate the virtual DOM, which is much faster than real DOM as well. Virtual DOM makes our application faster and there is no memory wastage, because when we talk about the virtual DOM, just like real DOM, the entire HTML DOM gets re-executed or re-rendered. The virtual DOM never re-renders completely. Only the changes affected into the DOM gets replaced. The virtual DOM works in 3 simple steps. Step 1 says that whenever any underlying data changes happens in the entire UI element or the DOM, the entire UI is re-rendered in the virtual DOM representation rather than re-rendering into the HTML DOM. So this is the virtual DOM. Let's say the change happens somewhere in this node where the yellow color is displayed. So only these changes will be re-rendered into the virtual DOM rather than re-rendering the entire DOM representation. Step 2 says that once the HTML DOM or a real DOM and the virtual DOM is compared, then the difference between the previous DOM representation and the new one is calculated. During this calculation, only the change which gets affected into the virtual DOM will be affected. Once this calculation are done, the real DOM will be updated with the only changes that have actually changed. We can think of this change as a patch. As the patches are applied, only the affected area. Similarly, in the virtual DOM, only the patches or the changes to the elements which are updated or changed in the real DOM only. So this makes our application faster and there is no memory wastage as compared to the real DOM to be modified directly. So when any change is occurred, first the virtual DOM is modified, virtual DOM is compared with the real DOM, and only the affected change gets re-rendered into the browser. This is how our implementation of virtual DOM exists in the React, which makes our application faster, robust and scalable for the real-time application. Thank you so much. Hello guys, welcome back. In today's session, we will be discussing about JSX, which is JavaScript XML. In this session, we will be discussing about JavaScript XML introduction, how JSX are used in React components, JSX attributes, their conditional rendering in React components and expressions. Along with that, we will talk about JSX cascadings or styles in React component. Basically, JSX are generally written in React components and any other scripting language as well, because JSX is a preprocessor that adds some XML syntax to JavaScript. In other terms, we can call it as a syntactical sugar to the JavaScript. JSX helps us to create a virtual DOM by returning the HTML along with the scripting along to be implemented by the XML. We can use React without JSX also, but JSX makes a React a lot more elegant and implement it in the XML pattern, which is easy to write and understand, and also it's faster. JSX is faster because it performs some optimization during compilation. Whatever JSX syntax you write, that JSX syntax is actually converted or compiled into the JavaScript, pure JavaScript. Let's say if you write H2 element in JSX syntax, it actually compile that in the JavaScript pattern or a language, where we use a create element method to create any H2 element in HTML. JSX is type safe, thus errors can caught during compilation. Errors are the most implemented part of the scripting or any programming languages. JSX shows you the compile time and erroneous errors at the same time when the compilation takes place. So this is an add-on feature of JSX. JSX is basically easier and faster to write the template because some XML syntactical sugar is being added to the JavaScript and more familiar with the HTML because it communicates in the terms of tags. XML consider the user-defined tags, whether the HTML consider the predefined tags. So it gives a syntactical sugar to the markup language to the JavaScript. Let's understand with practical demonstrations. In our previous session, we had created a React Fundamentals project in which we discussed that under the SRC folder, we have index.js, which is the entry point of React application, and using the React DOM, which is a package already installed during the creation of the application using create React DOM, the app component gets rendered as a root component. This add component will actually display its content to this get element by ID root. When I'll see this get element by ID root, within the same repository, we have a public folder where index.html is placed, as I discussed earlier, which is a page template that renders the React component. Once I'll open this index.html, here it looks like a similar HTML syntaxes where we have a div which has an ID property, ID attribute which has root name. So this entire index.js element will be rendered into this root. Post that, as we discussed, the root component is the app component. In SRC folder, we have app.js, which is our initial root component. We can see that here we have a class component. Under this, the render lifecycle method is executed that returns the entire JSX syntax or the markup tag. Once, if I remove this and I would like to write down my own implemented HTML to be executed as a part of the component, I'll simply remove this and I'll try to write down a div under which I simply write down hello world. Now, if I execute this React project, I just render this with npm start. So I'll see that this div is actually returning hello world. This entire return JSX, which is a JavaScript XML, will be returned by this component when this component will be rendered to this root component actually. So once this application gets executed successfully, I'll get this hello world. That if I want the multi-line elements to be returned, if I simply go to my app.js and I write, rather than this div, I'll simply write h1 hello world and I write a second element h3. This is my root component. Once I'll write more than one element into this JSX syntax, the first rule says that JSX should have one parent element that gets returned by this render method. So when you have nested elements or more than one elements in one JSX, we need to wrap it within a container, one container. Most probably that container should be div. Post that, I can simply wrap this h1 and h3 element into the div. So that's what we discussed. If we have more than one element in one JSX return, then we need to wrap it with one container element. we most probably use div as a wrapper for any multiple elements in JSX to be used in React component. Post that, I'll simply go and check my both elements gets rendered successfully. This is how we write the JSX in our React components. We further have some rules to use or write the JSX. Next, we have JSX attributes. In JSX attributes, we use the tags which have a tag name, attribute and their children. If an attribute value is enclosed in curly braces or quotes, then the value is string. But if we wrap the value in curly braces, then the value is enclosed as a JavaScript expression in terms of React component. Just like this, we have two elements. One is div and another is myCounter. Here div is an HTML element and myCounter is another React component. In div element, we have an attribute class name and its value which is written in double quotes. As we discussed, if an attribute value is enclosed in quotes, it is actually a string. But when we do not write any attribute in double quotes, such as we have a count attribute, and this attribute is not written in double quotes or single quotes, it is written in curly braces. This is actually implemented as in JavaScript expressions. Now, further we will be soon creating the multiple components in one React project and we will render in this way. Now understand what is JSX expression basically. JSX expression needs to wrap within curly braces. You can write it into your nested elements as well as you can directly write it into your parent component as well. For example, if I simply go to this element where we have a P tag, under this P tag, I just wanted to write down one expression where I just wanted to calculate 10 plus 20. I'll simply write this calculation or an expression in curly braces. So once I'll see over my render, 30 is the output. JSX expression does not encapsulate the conditional constructs. Thus, the conditions like if, else, nested if, else are not allowed. If you wish to write down any conditions or conditional constructs for making some decisions, you can simply use the conditional or ternary operator, which is a question mark operator. Such as if I go to my project and here I create one variable outside this render. Let's say I'm having var num equals to 5. I should use it inside the render actually. Afterwards, I would like to make some decisions. I say if num is greater than 0, make some ternary decision and return positive. Otherwise, return not positive. I hope we are aware about this syntax. First, we write the condition. After writing the condition, we make a question mark, which is a ternary operator. If this condition is true, then just after this question mark, the expression that is returned will be your output. Otherwise, just after the colon, whatever rendering you want, you just display it over here. So once I'll save this and I'll go back to my browser, I can see the output is positive because num is 5 and 5 is greater than 0. Simply if I write this 5 as minus 5 and I'll just save this and I'll see the output is not positive. So whenever you write some conditions or you wish to make some decisions in your component, you can use the ternary operators. Conditional constructs are not allowed. After that, we also do some styling or to use some inline styles or the cascading implementations in our React component. JSX styles with both ways, inline styles, also the embedded styles or external style sheets as well. External style sheet I already discussed. If you wish to write some cascading for this app component, I have this app.css and I just import this app.css into my app component, and I can use those style sheets here. But sometimes we require the inline styles. Then in that case, we just need to simply remember one rule. While using the inline styles, we need to use the camel case. Camel case means when we start writing any tag, the first character of the starting of the property should be in lowercase, and in between wherever the differentiation would be required, we just write it with the capital case. Simply go to the component and start writing your style sheets here. I'll simply go to my component and I'll just write it inside this render method, just like this var my style. I'll write few styles where I say font size is 20 pixels and color is somehow navy. We should write down this color in quotes. We should separate the properties by comma. Here we can see that while writing the inline styles, we need to use the camel case. In generally, cascading font size is written as font hyphen size, but where I want an hyphen, I separated that property name with the capital S. That is known as a camel case. React will automatically append the px, which is a pixel, to make this number on the specific elements. And then color is as it is written in the single quotes, whichever color you want to be applied in your style. Post that, just go to your element wherever you would like to use this style. Let's say I would like to write down one more P, and I just write down here footer here, and I just simply append the style sheets, inline style sheets, using the style property. As we discussed, if I write this into the double quotes or single quotes, it is a string. But if I write this into the curly braces, it would be the expression. And just write on the style that you have append into your component. I'll simply go and I'll see this footer here is displayed blue in color. And if you would like to make this size more bigger, I can simply see the differences which I made some changes into my component. So by this way, React recommends some inline styles, or if you would like some external style sheets to be implemented, create a separate CSS, import that CSS into your React component and use that. Later we have some other cases as well. If you would wish to make some single line comment, the single line comment looks like, I'll just simply write down single line comment. There is a shortcut key in Visual Studio Code, Control/, and here I can see that 1/ star asterisk, whatever statement or a comment you write, but you need to keep your entire comment inside the expression. It comes by default. If you have multi-line comments, line 1, line 2, and line 3, and you would like to comment these 3 lines together, just select this and use a shortcut Control/. Otherwise, you can just write it manually as well. It will keep your entire comment into the curly braces. Along with that, it will separate it with the slash, asterisk, and asterisk slash ended by that. So when writing comments, we need to put curly brackets. When we want to write comments within children sections of a tag, it is a good practice to always use curly braces when writing comments, since it is so consistent when writing the application project implementation as well. So that's what we discussed. React component starts with the uppercase. We need to wrap the HTML elements with one container element, that is a root element inside the JSX syntax. JavaScript expressions can be used inside of JSX using the curly braces. It is a good practice to always use curly braces when writing the comments, whether it is a single line comment or multi-line comment. While writing the inline styles, we need to write down the style properties in camel case syntax. We should use the class name and HTML name for XML attribute names instead of class and for. Generally, when we write some cascading classes, we write a class property. For that class property, that property is renamed as class name. Further, we'll be discussing while creating the cascading style sheets in the form of classes and IDs. Thank you so much, guys. Keep learning.